Hello, everyone. Welcome back to Python Challenge for All.
So what were we doing last time? So revisiting prime numbers. And yes, we were visualizing the time comparison of the time needed for computing using a naive approach, and sieve of Eratosthenes. Okay. And then we found that it was there's a big difference. But today, lastly, let us focus on the number of primes or percentage of prime numbers for different scales, ranges of numbers. Okay, so let's open the last E4 file, connecting. And okay, let's open the last box. Okay, let's run the last box. Maybe where were we? Last here. Okay, so today we're going to use only the Erato. Okay, so we're gonna where is Erato? Okay, here's Erato. Let's define it, and then let's run the Erato from starting from 100 range, 10,000 million, and 10 million to 20 million. And we found that we could go up as far as to, okay, we forgot to import time. So let's see, maybe we can just go ahead and import time. And then, yeah, let the program do the work up to 50 million. In the meantime, let's think about the idea. So here's PNT. PNT stands for prime number theory. So let's see if we can check the kind of correctness to prime number theory. Okay, so okay, I hope you're interested in it. So what does prime number theory say? It says the percentage of primes, or the ratio of primes, multiplied by, say, log x. Okay, so usually the ratio is denoted as pi of x divided by x. That's a ratio of prime numbers up to the number x. And when multiplied by log natural number of x, it approaches to 1.0. Okay, so let's check that. Okay, let's see. It's okay, it's done. So we have all the prime numbers count of, say, here it says 3 million, about 3 million out of 50 million. Okay, so let's check that. Okay, we don't need this. Okay, so let's see. We have now the list of prime numbers in. Oh, I forgot to put it in the sorry, I forgot to put it in a list. Oh yeah, prime number list 2, PN2L, keeps the prime numbers up to. Okay, so let's see. Good. PN2L print. Okay, let's check that. So and okay. So let's check it compared with the ulim-L. So to check that, we need to multiply. Let's see. Let's make empty boxes here. So what we need to do is let's see. For hmm, okay. Let's see, X and Y in zip. This is how we can combine two lists. Okay, so ulim L, P and 2L. So we want to check the let's see, print of say X divided by, so let's write both X and Y, X divided by Y, and X divided by Y times, let's see, that's, maybe we need to import math so that we can calculate natural logarithm of X. Okay, import math. And then we can calculate the times math dot log X, okay. Okay, let's see how this sequence converges to. So something is wrong. What is wrong? Okay, sorry. Apparently what we need is y over x, not x over y. Okay, that's right. So let's see that. Okay, so this is what we do. So x, now here x is here. Count of prime numbers y here. Ratio of prime numbers here on the third column. And ratio of prime numbers multiplied by ln x is here. So as you can see, the last column approaches to 1.0. And this is what PNT, prime number theory, first maybe proposed or considered by Gauss, tells us. So maybe if you're interested, you can check that. If you go further, it approaches to 1. And that's a very interesting theory, which was later, much later, proved using very complex mathematical foundations. Okay, I hope you like this kind of thing. Okay, if you are interested, please go on and study about it. Okay, so let's save it. And let's go back to the slide. So multiply the ratio by each n. N means the log of large n. But anyway, so we found that P and T tells us that that ratio in the last column approaches 1. Okay, let's move on to today's topic. So moving on to desktop environment. So, so far we've been studying the grammar of Python and also kind of introductory use of Python using Google Colab. So from today on, we're going to you moving on to desktop environment so that we can use personal, Windows-based or PC-based application development and also desktop applications. Okay, so first, what we need to do is download and install Python. So go to your browser. Okay, maybe open your browser and you can search for python.org. Okay, python.org. Then maybe you can go to this page. This is where we can download desktop version of Python interpreter. So from downloads tab, you can download best Python suited for your system by clicking here. Okay, so by clicking here, you can download it onto your, as you know, download folder. And then by double clicking this, you can install the Python interpreter onto your system. Okay, let me do it. Although I already have it. So the point is, yeah, here, maybe you can upgrade now. In my, yeah, in my case, it's upgrade now, but for your install. And then the important thing is, okay, let me go on. So go to Python tutorials or copy or paste. Maybe I will put a link in the description box below. And then download the installer from download folder, download tab, and install by executing the installer in the download folder. Be sure to check add to path at the bottom because that's easier to do. Okay. And then run the installer so that you can go ahead and install it. Okay. When you are done, maybe I will stop it because I don't need to upgrade it. Okay. Next thing is, okay, go to the desktop and make a, let's see, let's go to the desktop and right click and make new folder called, say, KPC working. Okay. This is how you can save your local Python files. Okay, so that you can easily find it. Okay, KPC folder on the desktop, on your desktop. And then start idle. Maybe you can do it first by going to the start button. Let's see it. By start button, you can find idle, IDLE, sorry, IDLE. And I think you can launch an idle. Here, you can open an interpreter. So as you can see, you can, for example, do calculation as before. You can do 2 plus 3 here. Okay. 6 plus 3 times 5 is 45 or something like that. Okay. As you are familiar, 7% 3 equals 1, something like that. Okay, this is how you can use the interpreter. And also, you can make a file by clicking from File menu, you can New File and open it. And you can put your code here. So let's see, what does it tell? Print integers from 1 to 10. For example, here, for I in range, say 10, okay, from 1 to write 11 here, colon, print I. Okay, so then you can run it by function 5 or run module. And that's run executable only after saving your folder. So save it onto your KPC working folder, which you just made in the maybe desktop. You can hold it, KPC working, and then run it. Okay. So maybe in my case, KPC and test 1, 0, 0. Okay. I see. Okay, sorry. So okay, no. You can save it anywhere you like as, let's see, maybe you can change it to documents and test 0, 1. Okay. And then run it, as you can see. I advise you to actually change, okay, by changing the working folder to your KPC working. That's easier for you. But anyway, as you have seen, you can play your Python code just like this. Okay. Okay, so that's all for today. Homework: find prime numbers using 20, using your idle environment. Okay, please come back with your new preparation, and let's continue the work and enjoy it. Okay, see you next time. Bye bye.